We will solve a problem on contact area of a tire that is moving upon a pavement. So the thing is, when a pavement goes over a surface, it has a contact area over the surface. If we look at this picture, you can see that this is wheel and tire, and it has a kind of circular contact area over there, and in this case a contact area like a rectangular in middle and two half circles at two ends. It's a kind of complete circular contact area. So we'll find the contact area considering the shape. Once we'll assume that the shape of contact area is circular. Here we have a different kind of shape. So for different shape, we'll find the figures. So before that, we'll find out the contact area. So how can we find out the area? To find out the area, we have a particular load which is 18 kip a single axle load, and a tire pressure. Tire pressure is 80. So if we divide the load with pressure, we'll find out the area, because pressure is equals to load over area. So from there we can find out the area as load over pressure. Again, we have 18 kip single axle load. So it can be seen as an axial system. Let's see, it's the top view. It's an axial, and it has for single axial load, it has two wheels there, and it has another two wheels there. So we have four wheels, and this 18 kip load is distributed to four wheels. So each wheel has a force of 18 over 4. So that would be, I think, 4.5. Yeah. So the load would be 4.5 keep for each tire or each wheel. So here we can find out the contact area dividing the load we have for each wheel, which is in keep, and pressure, which is 80 psi pound per square inch. Sorry, I should write it as lb. So here I need to convert keep in terms of pounds. So for that I will multiply it 10 to the power 3. It's pound per cube. So we'll get a contact area of 4.5 times 10 to the power 3 over 80. 56.25 square inch. Okay. First of all, we are asked to find out the most realistic contact area. So how do we understand by realistic contact area? For most more realistic, we consider a rectangle there, and a circle over there. Circle over there. And the length of this rectangle is 0.4 L up to this, and the remaining is zero point 0.3 L, like up to this. from here to here, 0.3 L, and the width of that is 0.6 L. For this realistic shape, we have a formula for length measurement, that is length will be equals to root over AC over 0.5227. I mean, if you consider this shape and you find out the uh, formula for area, you will find out like this: AC is equals to 0.5227 L square. From there, we're trying to find out the length, since we know the contact area, that is 56.25. From there, we'll get a length of 56.25 over 0.527. We get a length of 10.37, and this length is the this total length. So now you can multiply 8.3 to get this length, and zero point 0.6 to get this length, and zero point 0.4 to get this length. So this is the most realistic shape. You'll find out the dimensions of all the things, multiplying it with L. What we have got 10.37 is in inch. So if we consider a rectangle shape, what it will be, and say we are considering rectangular area, where contact area is rectangular. For that, we will assume that we have a rectangle over there, and its the dimensions are fixed. That is, this the width will be zero point 0.6 L, and this length will be 0.87, sorry, 0.8712 L. For that, you will get an equation for area, and we know the area, that is 0.6 L multiplied by 0.88712 L is equals to 56 56.25. So from there you will get an dimension, that is L. We'll divide 56.25 by zero point 0.6 multiplied by 0.8712, and then we'll root that. We'll get a length of 10.37. Let me check once again. Did I made any mistake? 56.25 divided by zero point 0.6 multiplied by 0.8712. I get 107, and I need to square root. I will get 10.37, right? 10.37 inch. So to get 60% of the length, 10.37 multiplied by zero point 0.6, it will be 6.22 inch, and it will be 0.8712. It will be just 9.04 inch, 9.03 inch. So considering rectangular area, we need this kind of area in finite element analysis, and we'll find out the another shape, that is if we consider layered theory. theory, where we consider two circles, and for that we have an area of pi r square, which is 56.25, and from there I can find out the value of r as 4.23 inch. So these are two circles. What do we mean by two circles? The contact area will form the overlapping of two circles, and it will have an area of 56.25. Uh, you may think that since it is two circle, I should to get the radius, I should divide the area by two. So, but we will not do that. You will find out why. Homework. Well, the radius will be for that 4.23 inch, and for that 4.23 inch as well. And for in other analysis, sometimes we assume that the uh, contact area forms single circle. For that, we will assume that the contact area has been adjusted by multiplying with 2. You will find out why, but to do the math, I will just do it, and you will get a radius of 5.98 inch. So, in this case, you will get a single circle, and it has a radius of 5.98 inch. So, this is quite important to find out the contact area. It helps you in many way for many calculations and analysis. So, this is all from this lecture.